Hello everyone and welcome. The Arizona Department of Education has created this video to help support the new computer science standards. This video will provide a brief overview of how we can define computer science and other fields of study that support computer science. Computer science combines the fields of computational literacy, information technology, digital citizenship, and educational technology. However, computer science is more than these individual parts and extends these fields to focus on understanding not only how, but why computers work. These important subjects support computer science, but they are not computer science. Common misconceptions about computer science pose serious challenges to offering high-quality computer science experiences for all students. The differences and relationships among these fields within computer science will be described in this video. Computer science is focused on understanding how and why computers work, the creation of new technologies, and the impact on society. Computer science is a discipline that makes the use of computers possible, has driven innovation in every industry and field of study, from anthropology to zoology. Computer science is also powering approaches to many of our world's toughest challenges. Some examples include decreasing deaths in automobile accidents, distributing medical vaccines, and providing platforms for rural areas to participate in larger economies, among many other things. Let's take a look at computational literacy, because computer science sometimes overlaps and uses computational literacy, but there are some distinct differences. Computational literacy is the general use of computers and programs. Some examples are computer applications, productivity software, internet search engines, and creating digital presentations for classroom and professional use. Computer science will focus on understanding computer technologies, why they work, and how to create those technologies, whereas computational literacy focuses on one aspect, how to use those technologies. This is one piece of the big picture of computer science, because no matter what discipline you go into, some programming is going to be useful. High academic standards developed at the state level are meant for all students and should have sufficient rigor to help prepare them to enter and succeed in entry-level post-secondary courses that require skills such as critical thinking, problem solving, and computational literacy. Amid concerns over an unprepared 21st century workforce, U.S. policymakers have placed increased emphasis on the subjects of science, technology, engineering, and math to ensure that youth are sufficiently equipped to compete in today's marketplace. As these types of jobs are on the rise, and with increasing opportunities, there will be a high demand for people with computer science skills in all fields. Computer science, in particular, has recently taken the national spotlight with large-scale initiatives at the local, state, and federal levels aiming to ensure that students gain computational literacy skills viewed as a new basic skill necessary for economic opportunity and social mobility. Computer science builds upon these concepts of computer literacy as well as other concepts to develop learners, users, and creators of computer science knowledge and artifacts. In addition to computational literacy, computer science is more than informational technology, but informational technology is another important piece of the puzzle. Information technology is the industrial applications of computer science. For example, installation of software. Information technology is the study, design, development, implementation, support, or management of computer-based information systems, including software applications and computer hardware used to store, exchange, and use information. IT professionals help ensure that computers work well for people, and IT professionals often have a background in computer science. Computer science is more than digital citizenship. However, we can't define exactly what computer science is without discussing digital citizenship. Simply put, digital citizenship is the appropriate and responsible use of technology. There are fundamentals of digital citizenship that are important to computer science, and these themes are found throughout the K-12 computer science standards, which include appropriate use of digital media, including the norms of appropriate, responsible behavior with regard to the use of technology. Again, digital citizenship is just one part of computer science. Yes, computer science and the new standards will empower students to be informed citizens who can critically engage in public discussion on computer science-related topics. However, digital citizenship is not concerned with understanding computer technologies, why they work, and how to create those technologies. Also, digital citizenship is about much more than online safety, or a long list of don'ts. It's also about the do's that help create thoughtful, empathetic, digital citizens who can wrestle with the important ethical questions at the intersection of technology and humanity. Those do's include using technology to make your community better, engaging respectfully online with people who have different beliefs than you, using technology to make your voice heard by public leaders and to shape public policy, determining the validity of online sources of information. This new lens focuses on empowering learners to be in community with others in online spaces and showing them that digital citizenship goes beyond conversations about personal responsibility. It's about being active citizens who see possibilities instead of problems and opportunities instead of risks as they curate a positive and effective digital footprint. Digital citizenship helps manage a healthy identity online and offline with integrity. It also helps with managing screen time, multitasking, and online presence with self-control. When educated, students recognize cyberbullying, they learn to protect their data and privacy, they can apply critical thinking in determining what is false and true information, and they can apply empathy to situations involving others' needs and feelings. Computer science includes computational literacy, information technology, digital citizenship, as well as educational technology, but again, it's still more than all of these individual parts. Educational technology is the application of computer literacy to school subjects, for example, collaborative editing of an online document. Educational technology involves the disciplined application of knowledge for the purpose of improving learning, instruction, and student performance. There are many types of educational technology that can be utilized in the classroom. Some common examples are using a word processing software to write an essay, using spreadsheets in math and science class to analyze data, knowing how to locate primary and secondary resources to study specific time periods in a history course. Other examples can include electronic whiteboards, flipped classrooms, desktops and laptops for student use, and virtual field trips. Educational technology is the use of digital teaching tools to improve the educational experience for both teachers and students to facilitate learning and improve performance by creating, using, and managing appropriate technological processes and resources. Computer science is often confused with everyday use of computers, such as learning how to use the internet and create digital presentations. Parents, teachers, students, and local and state administrators can share this confusion. A recent survey shows that the majority of students believe that creating documents and presentations and searching the internet are computer science activities. As we think about implementing the new 2018 computer science standards, it's important to understand what computer science is and how other technology fields influence and support computer science. To summarize again, remember, computer science is focused on understanding how and why computers work, the creation of new technologies, and the impact of these creations on society. Computer science is also the discipline that makes the use of computers possible. It's driven innovation in every industry and field of study, from anthropology to zoology. Computer science is also powering approaches to many of the world's toughest challenges. The lack of opportunity can be discouraging, given public opinion and recent job statistics on computer science, such as Americans believe computer science is as important to learn as reading, writing, and mathematics. Most parents want their child's school to offer computer science. Since 2010, computer science ranks as one of the fastest growing undergraduate majors of all STEM fields, and advanced placement computer science is the fastest growing AP exam, despite being offered in only 5% of schools. Jobs that use computer science are some of the highest paying, highest growth, and most in-demand jobs that underpin the economy. And computer science is defined as part of a well-rounded education in the Every Student Succeeds Act. Understanding the importance of computer science in the world today, rigorous state standards have been developed based on the K-12 computer science framework. This text was designed to help states develop and implement computer science standards. In this framework, essential core concepts and practices have been identified and are meant to be integrated throughout classroom instruction. The 5 core concepts of the framework were not designed to serve as independent units in a course or separate topics defining entire courses. Instead, the framework's concept and practices are meant to be integrated throughout instruction in any course learning any topic of study. The core practices represent the behaviors that computational literate students use to fully engage with the core concepts of computer science. The framework's learning progressions describe how students' conceptual understanding and practice of computer science grow more sophisticated over time. The concepts and practices are designed to be integrated to provide authentic, meaningful experiences for students. Thank you for spending some time and watching this video. Please visit the Arizona Department of Education's website for resources on the new computer science standards and professional development opportunities.